So go guys, this is the second part of this little series. In this part we're going to create our circuit system. So the first thing to do is to create a new script for the Bezier curve, because the Bezier that we are now calculating is just calculated by the editor script, but we don't have the editor script in the game, so we need to create our own script. This is a basic class with only a function that is a public static one, and this called and this a cubic one. So I just going to copy this because it's pretty long. So there we are. This is the complete function, and this is just takes the start and the start tangent and the end tangent and the end, and uses this formula, this extremely long formula, to calculate the cubic Bezier curve. This is obtained by overlapping more than one curve, and this is just the complete expression. So we copy this inside there, outside, over there. So this is what we need for our Bezier. We can just close this. We don't need this no more. So what we are going to do now is to use the path creator script inside this. In the start function we need to calculate all of our game objects to position it. These are circuit limiters. I now import the circuit limiter. So another thing that I don't want to do later is to correct the box collider of the player. So first thing, save the prefab as a prefab variant. We will need this later. And now change the player, the edit collider, and this collider should use all the shape of the boat. Why this, you can ask, and this is just basically because the collision with the circuit limiter, I want this to be correct, so I need also to have a correct boat model. So now we can go inside our script. I don't know, I need to explain the method in which this is all working. So we go to the circuit creator. We just need to check this distance, and in this distance, this is 1 unit of time. As the definition of the Bezier curve, this is the curve in 1 unit of time. So for each change of time, when the time reaches let's say 0.05 seconds, we put a new circuit limiter, and this goes till the end of the curve. If there is too much of them, we will delete the two close of them together, but this is later. So first thing is to generate all of this. So to make this, we need to go in the start script. Inside this, we need to declare some variable, so we declare it right there, the game object array for the limiters, and a way to understand what the limiters number is. Then we need the time between each step, so time between limiters. We need to know what is the circuit limiter. Right, this is serializable field game object. Why I'm trying to put them game object there with limiter. is the amplitude of our circuit. So the length, the width of the circuit. Well, width is better. Width is a better attribute. So in the start function, so we need to know that the limiter's number is equal to it is an int, so it needs to be cast as an int, and is the math floor of 1 over the time between each limiter. Obviously the limiter's number, while the limiter's array is equal to a new array. So we need to define the array game object, and this array is, you can see now, we should have all the secret limiter on point, and obviously we need to set all the variables. So secret limiter setted with not now, and this can be set to whatever value you want, from 0 to 1 obviously. And as you can see, there is all this little circuit limiter. Maybe we need to make them bigger, so 555 is enough. I don't know, let's see. Okay, maybe too much. Okay, maybe just 2 is enough. I don't remember the other dimension for this. Okay, something between this 3.5. This is pretty much tweaking on your preferences. Okay, this looks like good, and as we can see in the circuit creator, we are following the right line. So now we need to calculate the direction in which we are moving along the curve. This is so simple, just do the same thing that we've done there, but calculate the direction, and it's just a subtraction of the 2 vector 3 points, and the second point is a little bit more forward than the previous one. So this value should be the smaller you can get. This 0.01 is just a small enough value to not have noticeable errors, but there is an error with this value. So theoretically this should be an infinitesimally amount, so something like 0.01. But we can't do this in computers, so this is a good approximation. So we need to go from the final position from the final position to this. So we need to declare first the final position, I think. I don't remember. Okay, no, just minus position, and then normalize this all. So now, giving the direction, we can use this to use the perpendicular direction times the width of this. So to the position we add a new vector 3, and to find the perpendicular to this vector, to the direction vector, we just swap the value and make one of them negative. So 0 for the y, as always. For the x, we are going to use direction dot z, and for the y, direction dot x. And one is negative, and we just multiply this all for the width. Okay, this should be perfect, and as we can see, if we increase the width to something like 3, we should get this offset by 3. If we increase to something more noticeable, Okay, as you can see, this is offsetted. Now, last thing to do is to duplicate this to do the other part of the line. So we do the same, we invert this, so the minus go to the other direction, so we get the other perpendicular vector. And another thing to change is that we need another place in this array, so we just do this by adding to all of this f round. We just add to all of this f round, so we just go with the count of the anchor times the limiter's number. Obviously, we also need to create a big array, a twice as big array. So this is all correct. Let's put this to a reasonable value. So this is all for this video. Yes, this works fine. Let's decrease the delta time so we have them more near together, maybe too much, so something like this should be enough. And as you can see, we can drive inside of this if I put on the joystick. Yes, obviously you need to tweak the circuit to accommodate your needs. There's a problem. I passed through the circuit limiter and I don't like this. So choose the last two things to do is to make these floats and to keep their position when they are moved. Applying a rigid body to them will move